Naming organic compounds. The rules. Rule number 1. The name is based on the longest continuous chain or biggest ring of carbon atoms. So taking this first example, in this first molecule, there are 1, 2, 3, 4, 5 carbons in the longest chain. So the 5 carbons in the longest chain would begin with pent. However, on the second of those carbons here, there is a branch, and the branch has 1 carbon, so we will call that a methyl branch. So the correct IUPAC name for this particular compound is 2-methyl pentane. 2-methyl pentane. Let's take a second example, this one here. So sometimes it's important to count carefully the longest chain of carbons. So here we've now got 1, 2, 3, 4, 5, 6 carbons in the longest chain. So that's then based on hexane. And this time there's a methyl branch, so we can consider this one to be a methyl branch now. And that would be on the 1/2 carbon of that chain. So this one, 3-methyl hexane this time, 3-methyl hexane. The second rule is that the numbers used are always the smallest ones possible, and you might have noticed that in the last 2 examples that I started numbering from one end rather than the other end. So for example, in this particular compound here, so we've got 1, 2, 3, 4, 5 carbons in the longest chain, so it's based on pentane, so it's pent. And then if we start to number from this end, 1, 2, 3, 4, 5, then the bromine group, this bromine substituent that sits here, would end up on carbon atom number 4. However, alternatively, we could number 1, 2, 3, 4, 5, which has lower numbers. So that's a 2-bromo group rather than a 4-bromo group. So the correct IUPAC name for this one is 2-bromo. Oops, let me undo that ink. 2-bromo pentane, like so. 2-bromopentane. The third rule is that if there are several different substituents, these are then listed in alphabetical order. So let's take a look at this example here. So in this example, we've got a total of 1, 2, 3, 4, 5 carbons again. So again, this one's based on pentane. We've got a bromo up here and a chloro down here. And if we start numbering from the left-hand side carbon as this is drawn, that would be 2 bromo and 3 chloro. B for bromo comes before C for chloro. So the correct IUPAC name for this molecule is 2-bromo. Remove that ink again. 2-bromo 3-chloropentane. 2-bromo 3-chloropentane. The fourth example, if there are multiple examples of the same group attached, we use di, tri, tetra, etc. To show this. So for this example here, we've got 2 carbons in the longest chain, so that's based on eth. Notice that we've got a CC double bond there, so that would end up with an ene group, ethene. And then we've got 1, 2, 3, 4 fluorine atoms attached. So this example will be called tetrafluoroethene. Now there's no numbering needed here because every fluorine is occupying a space and those fluorines cannot be anywhere else. So tetrafluoroethene is an unambiguous representation of that molecule. Some organic compounds, instead of having a chain of carbon atoms, will have a ring of carbon atoms. So we use this term cyclo to describe that. So a fairly straightforward example first. Here we've got a compound where there's 1, 2, 3, 4, 5, 6 carbons in the cycle. So that will be based on hex. It needs to be cyclo because it's in a cycle. And we need to look at this bit here, which is an alkene functional group. So we need to communicate that. So this one will be called cyclohexene. In this case, there's no need to write a number because that CC double bond could be between either of those carbons, any of those within that ring, but it would be the same molecule that would just be rotated around, so no numbering needed here. In a second, slightly more complicated example, this one here has got 4 carbons in the ring, 1, 2, 3, 4, so that would be based on cyclobute something or other. There are some substituents. Up here there's a methyl group, methyl, and down here we've got 2 chlorines, so dichloro, and in the naming the chloro part of that would need to come before the methyl part of that. We also need to think carefully about the numbering in this case. If we call this bottom right as it's written carbon atom number 1, then we would have 1, 1, 2. So that's the lowest possible numbers. So in this example then, the numbering would go 1, 1 dash dichloro. So the chloro is the bit that counts there, not the D. The C for chloro counts in that case. Dash 2 dash M for methyl. And then cyclobutane. So 1, 1 dichloro, 2 methyl cyclobutane for that one. So we've now met most of those rules for naming organic compounds, certainly the rules that you need at this stage of the game. So before you move on, please check that you've got the definitions booklet to hand, which helps you to identify different functional groups. We'll focus on the following ones for now. These are the ones that you tend to meet in the first year of the A-level course. So halogenoalkanes, alkenes, alcohols, aldehydes, ketones, carboxylic acids, nitriles, and primary amines. If you need to pause the video at this stage to go find that definitions book and spend some time reading that and having a look at those, familiarising with those functional groups, then please do so. So it's time for some practice of these skills. So for each example, I would like you to pause the video clip, try to name the structure, then press play and see how you got on. Keep examples with annotations to help you to develop your skills, please, whilst you're working. So this is the first example. Have a go. Okay, in this example then, there are 4 carbons in the longest chain. 1, 2, 3, 4, like so. There's also an OH group, so this is an alcohol and ends in an OL. And this one here is a methyl group, like so. So the correct IUPAC name for this compound is 2-methyl butan-2-ol, like so. Now I would also like to use this information to help you to understand different types of formula in organic chemistry. So if we have a look at this example that we have on the slide here, this is called a displayed formula. Now the displayed formula shows all of the atoms and all of the bonds present in that particular compound. But we could also show this as a so-called skeletal formula. So the skeletal formula does almost the opposite to that. It shows a minimal amount of detail and it shows lines which contain saturated carbon atoms at each end of the line unless it says otherwise. So let me draw this out and then it might make more sense. Here we've got 1, 2, 3, 4 carbons in the longest chain. So that represents CH3, CH2, CH2, CH3 at the moment. But of course we don't have that in this compound. On this central, on the second carbon atom, should I say, we've got an OH group like that. And we've also got a methyl branch which looks like that. So the skeletal formula of 2-methyl butan-2-ol looks like this. So I would very much like you to try to draw skeletal formula as well as the displayed formula for each of the examples as we work through. Let's try the next example. So try naming this one first. Try naming it, then do the skeletal formula. So here we've got 1, 2, 3, 4, 5 carbons in the ring, and substituents that we need to think about Br there, a CH3 here, and a Cl up here. So we've got a bromo, a methyl, and a chlorine. And we need to think about the numbering here. So I think we ought to be calling this first carbon number 1. So we've got a 1, 1. Then that takes us to 2 and 3, like so, for the naming. So the correct name of this compound then, 1-bromo, -3-chloro, -1-methyl cyclopentane. The reason for that being 1-bromo, Br before the Cl, 3-chloro, 1-methyl cyclopentane. So this is alphabetical rule in practice here. And in terms of the skeletal formula, we need a pentagon with 5 carbons like so. 1, 2, 3, 4, 5. On this one, let's have a Cl, and on this one, let's have a Br and a CH3, just like that. Let's try the next example. So this time 2 carbons in the longest chain, and then we've got Br and a Br, an I, a Cl, and a Cl. We better call this one carbon atom number 1, this one carbon atom number 2, so that we've got 3 number 1s and 2 number 2s in the naming. So this then becomes 1, 2-dibromo, -1, 2-dichloro, -1-iodoethane, like that. And from the skeletal formula example, okay, if we put carbon and carbon like so, on this first carbon then we also need an iodo and a bromo and a chloro, and on the second carbon we also need a chloro and a bromo, like that. So that's the skeletal formula of 1,2-dibromo, 1,2-dichloro, 1-iodoethane. Next one, reasonably straightforward, but something to remember here is that this carbon of the nitrile group also forms part of the longest chain. So we would call this one butane nitrile. Important not to forget this E here, okay, butane nitrile. And so with the skeletal formula, we've got 1, 2, 3, 4 carbons, and this end carbon then is triply bonded to a nitrogen atom. So, hang on, let me erase that bit. Let's try that again. Pen's gone a bit funny there. Nitrogen here, and that needs to be a triple bond to that nitrogen. Okay, C triple bond N at the end there. Next one then, let's look for the longest carbon chain. So the longest carbon chain looks like it's going to be 1, 2, 3, 4 here. We've got to think about the alkene group, the E in there. We've got to have this methyl group and another methyl group here. So the correct name for this compound is going to be 2,3-dimethyl but-1-ene. 2,3-dimethyl but-1-ene. From the perspective of the skeletal formula then, so 4 carbons in the longest chain, 1, 2, 3, 4. Between the first and the second there's a double bond. There's a methyl group on the second one, there's a methyl group on the third one. 1, 2, 3, 4, and then 2 methyl groups there. So 6 carbons altogether, that's correct. Next example here, so this new functional group on the end here is a carboxylic acid, and so the end of the name would be oic acid, something oic acid, like so. We've got 1, 2, 3 carbons in the longest chain, and there's 1, 2 methyl groups here. Now that carboxylic acid would always be counted as the end number 1 carbon in these examples. And so this one would be called 2,2-dimethyl propanoic acid. Let's do that skeletal formula. So 1, 2, 3 carbons in the longest chain. This end one has got the C double bond OH as part of it, and this second one has got 1, 2 methyl groups coming off it. Next example then, this is a different functional group again. This one here is an aldehyde functional group, so it ends in al. That's the only other thing that we really need to think about here. 2 carbons, so F, al. Again, be careful with the vowels here. 2 carbons in the longest chain, 1, 2, but this end carbon has got a C double bond O attached to it like that. So that's the skeletal formula. Next example then, this functional group here is an example of a ketone, so it would end in -one somehow. Here we've got 1, 2, 3, 4, 5 carbons, and it's important that we notice that that C double bond O is on the 3rd carbon in, and so the correct name of this one, pentan-3-one. 5 carbons in the longest chain, 1, 2, hang on, let me just change that over, pen's gone funny again. 1, 2, 3, 4, 5 like so, and on that 3rd carbon the C double bond O, just like that. So in this final example, we've got this functional group here, which is called an amine functional group. Only 1 carbon in the chain, so we will call this methylamine. Let me sort the pen out again. Methylamine. And then the skeletal formula would just look like 1 carbon attached to an NH2, just like that. So now you should be in a good situation to go away and have a practice of some of these examples using the worksheets provided. Have a try.